In this video, we will look at some common issues with connections, what to look for, and how to resolve them. An infrared emitter or bug is used to convert serial communication to flashes of infrared light, emulating a device's remote control. This light is not visible, so it's not always easy to see if the emitter is working. The Crestron IR-P2 infrared probe also emits visible light for debugging purposes. This allows a technician to see when a command is being sent. While you can't determine which command is being sent, you can at least see that something is being sent and that the wiring is correct. If the IR-P2 does not flash, the first thing to try is reversing the connections. As shown in the picture, each IR output has two pins, signal and ground. The emitters only work one way around and will not be harmed by being miswired. Swap the emitter wires on the screw terminals and see if the IR bug flashes when a command is being sent. If this does not work, try a second IR-P2 in case the first has become damaged. You can also check for a cabling issue by trying a probe directly connected to the processor. If you're unable to get the probe to flash, the problem is likely to be in the program code. If the IR probe flashes but the device does not respond, check that it has been placed correctly on the device. It should cover the IR sensor on the device. If the remote control is available, use this to find the best position for the IR probe. If the device still fails to respond, the problem is likely to be in the program code. For serial connections, a common failure is the pin configuration in the connectors. There are many different configurations depending on the standard that's being used. An example is shown here. If a device is not responding, an easy test is to swap transmit and receive. Typically, transmit on the processor will go to receive on the device, and vice versa. As most Crestron processors now use screw terminals for the serial connections, it's quick and easy to swap these over and test. You will not damage anything by doing this. However, it's good practice to ensure both devices are powered down before making the change. If this doesn't fix the problem, you will need to obtain the pin configuration, or pinout, from the manufacturer to check that the wiring is correct. Serial has many options with regard to protocol, speed, and flow control. These options must match on both devices. If this needs to be changed on the Crestron side, it must be changed by the programmer. It's not possible to check or change this elsewhere. You may be able to configure the device, but will need to know the settings used by the programmer. Cresnet is a very reliable connection method for Crestron devices. Cresnet issues are normally due to one of three factors: wiring, power, and identification. Cresnet is very flexible in terms of wiring configuration. You can wire each device separately, wire them in series, or with a split connection. Make sure you do not make a loop. Ensure that the wiring is of good quality and properly terminated. Most Cresnet devices require power. The power requirement for any device is listed in the specifications of the device in the manual and on the website. It's important to make sure that the Cresnet power supply has adequate power for all of the devices on the Cresnet network. Cresnet IDs and device setup have been covered in a previous video. Remember to use the network device tree view within Toolbox to get a view of all the devices in the system in order to check that they're online and IDs correctly. Wireless connections can be harder to debug. Many Crestron devices use infiNET EX. Some Crestron devices, along with other devices in the system, can also use Wi-Fi. If the wireless network is not set up properly and the information is not able to be received by the device, it's like cutting the wire. Wireless information is transmitted in waves through the air. Think of it like a ripple in a pond. The sender creates a ripple by dropping a rock. The receiver is like a floating object that moves up and down with the waves. The air is shared by many things. If the waves interfere with each other, the communication will not be successful. If many rocks are dropped in the same pond, then the receiver will not react properly. infiNET EX and Wi-Fi are both in the 2.4 GHz frequency range, along with many other connection types, but they can coexist if managed correctly. Within the available frequency range is a certain amount of space available for traffic, or bandwidth. Different wireless technologies use a different amount of space. Wi-Fi channels use quite a lot of space, with a bandwidth of 22 MHz. infiNET EX channels are much slimmer, at 2 MHz. Here, this is visualized as a highway. You can see the available infiNET EX channels as lanes on the highway. As long as all the cars stick to their lane, they will not interfere with each other. Wi-Fi channels, on the other hand, take up more lanes, shown here as trucks. It's very easy for Wi-Fi channels to interfere with infiNET EX channels. With proper setup, however, there is room for both Wi-Fi and infiNET EX. It's important to conduct a wireless survey with some third-party software to properly set up the channel allocation in the system. Shown in this table is another representation. You can see that if Wi-Fi channels 1, 6, and 11 are used, then infiNET EX channels 15, 20, 25, and 26 are available. More information on wireless setup can be found by searching Wireless Best Practices on our online help.